Physics has just cold, hard facts. But what if I told you one of its biggest breakthroughs was actually born from a bitter family feud? Yeah, this is not going to be your high school lecture on the photoelectric effect. This is the story of a scientific tribe at war with itself. That's right. I mean, this wasn't just some friendly scientific disagreement. It was a full-on showdown, a clash of ideas so fundamental you could really call it a tribal dispute over the very nature of light itself. And it was going to take a wise elder to finally settle it once and for all. Okay, so let's set the stage for this dispute. On one side, you've got the established ruling tribe, the masters of classical physics. I mean, these guys had laws that had governed science for centuries. But on the other side, a young, radical new tribe was popping up with a completely different idea, challenging pretty much everything the old guard believed in. So let's meet the tribal leaders. Leading the classics, you had James Clerk Maxwell. For him and his crew, the law was gospel. Light is a continuous wave, like ripples in a pond. But then, leading the moderns was Max Planck. And his claim was, well, it was nuts at the time. He said light isn't a wave at all, it's a particle, a tiny little packet of energy he called a photon. So wave versus particle. The battle lines were officially drawn. So what kicked this whole thing off? Well, every good conflict needs a trigger, right? For this one, it was this pesky little experiment called the photoelectric effect. See, when you shine light on a piece of metal, sometimes it knocks electrons loose. The problem was, the way it was happening just didn't make any sense under the old wave theory. The classics rulebook was failing them, and they had absolutely no explanation.
So into this whole mess steps a wise elder, a respected mediator we're going to call Sheikh Einstein. He saw the two tribes just arguing back and forth and basically said, enough, we're going to settle this, but not with opinions. We're going to settle it with facts. And he designed an experiment so clear, so perfect, that it would force one side to admit they were wrong.
The central question Einstein posed was actually pretty simple. We know light can free an electron from a metal surface, but how? And to explain it, he came up with this brilliant analogy. Let's just imagine the electrons are sheep in a pasture. Okay, so stick with me here. Each one of our little sheep, that's our electron, is tied to the metal with a rope. This rope represents the energy that's holding it there. Now in physics, we call this the work function. It's the absolute bare minimum amount of energy you need to snip that rope and set the electron free. So, if the work function is the rope tying the sheep down, what's going to cut it? Well, Einstein said that's the photon, that little particle of light. The energy of a single photon acts like a pair of scissors. The only question is, are your scissors sharp enough for the rope? And this simple analogy perfectly explains the three things that can happen. Okay, outcome number one. You've got a high-energy photon, that's a big, sharp pair of scissors. It just snips the rope, no problem, and has leftover energy to give the sheep a little kick and send it running. Outcome two, a threshold photon. This is like an exact size pair of scissors. It's just strong enough to cut the rope, but that's it. The sheep is free, but it doesn't go anywhere. And then there's outcome three, a low-energy photon. These are tiny, weak scissors. They just can't cut the rope. And this is the super important part. It doesn't matter if you have a million of these tiny scissors. That rope is not breaking. All right, so with the experiment done and the facts on the table, Sheikh Einstein calls the two tribes together. It's time for the final debate. He lays out 4 key points, 4 questions, and demands that each tribe explain the evidence based on their theory of light. So let's run through this debate point by point. First up, when do the electrons get released? Planck's moderns said only when the light's frequency is high enough, when the scissors are big enough. But Maxwell's classics said, no, brightness is what matters. If the light is bright enough small waves should eventually do the job. Well, the experiment showed Planck was right. Next question, what gives the electron its energy? Planck said it's the frequency, the size of the scissors. Maxwell argued it's the intensity, the number of scissors. Again, the facts sided with Planck. Point 3, is there a link between the light's frequency and the electron's energy? Planck's theory said, yep, a direct one. Maxwell said, nope, no relationship at all. That's strike 3 for the classics. And the final nail in the coffin, how fast does it all happen? Maxwell's wave idea predicted a time delay, for the energy to build up. Planck's particle idea predicted it would be instant. And what did the experiment show? It happens in a flash. 4 points, 4 wins for the new guys. It was a total checkmate. So when the dust settled, it was a complete knockout. For every single question that Einstein asked, the beautiful old classical theory totally failed. It just couldn't explain the facts. Maxwell's tribe was completely stumped. The experiment had spoken, and their old laws were officially broken. So, with the debate totally over, Sheikh Einstein stood up and basically laid down the new law of the land. He wasn't just picking a winner, he was literally writing the first chapter of a whole new rulebook for physics, quantum mechanics. And its core principle? Man, it was so elegant and simple. One photon frees one electron. Period. It's a one-on-one deal. The brightness of the light, which is just the number of photons, that doesn't matter for freeing an electron or for giving it energy. All that counts is the energy of that single photon, which is all about its frequency. And from there, he laid out the new laws, turning all those debate points into solid principles. Rule 1. An electron only gets freed if the photon's energy is bigger than the work function. The scissors have to be big enough. Rule 2. The electron's speed comes from the light's frequency, not its brightness. Rule 3. The higher the frequency, the faster that electron zips away. And Rule 4, this whole thing happens instantly. These 4 laws became the bedrock of our quantum understanding of light. Okay, so a bunch of physicists had a big fight over a theory a century ago. Why should you care today? Well, because settling this feud didn't just give us a new theory, it gave us a new world. The victory of this quantum idea unlocked technologies that literally define our modern lives. Seriously, look around. Every single time you take a picture with your digital camera or your phone, you are using the photoelectric effect. That little sensor that automatically adjusts your phone's screen brightness? Yep, photoelectric effect. Solar panels on a roof, turning sunlight straight into electricity? That's the photoelectric effect on a massive scale. Automatic doors, night vision goggles, all of it, every single thing, comes directly from winning this tribal feud and finally understanding how light really works. And that kind of brings us to a final, pretty wild thought. This whole story proves that science isn't some static book of facts. It's this messy, dynamic, sometimes even hostile process of discovery. It really makes you wonder, doesn't it? What deeply held scientific truth that we all accept today is just waiting for its own pesky experiment, its own Sheikh Einstein, to come along and spark the next great tribal dispute?